Hello sir, my name is Ankush Karmakar. I am a second year student of Electronics and Communication Engineering Department. My role is 3490324046. Today I am going to present the classification of signals. At first, we have to know what is a signal. A signal is any physical quantity or dependent variable or function that depends on one or more independent variables. Example, voltage across circuit, sound pressure in the air. A signal is like the messenger while the system is the processor acts on the signal. You can classify the signals in various types like continuous time and discrete time signal, determinant and non-determinant signal, periodic and aperiodic signal, even and odd signal, energy and power signal, casual and non-casual signal, analog and digital signal, etc. At first, we will discuss about the continuous and discrete signal. A continuous signal is a signal whose amplitude is defined for every instant of time. Its characteristics are the independent variable is continuous. It can take any real value. The signal's value changes smoothly without any sudden jumps. Example, voltage output of a microphone as it records sound. Below is the graph of a continuous signal. Discrete signal, a signal that is defined for only at specific separated points in its independent variable characteristics. The independent variable takes discrete values like integers n equals to 0, 1, 2, 3, etc. Not every possible value represented as separate dots on time axis. Example, digital audio sample. Below is the graph of a discrete signal. Deterministic signal and non-deterministic signal. A signal whose values at any time can be exactly predicted using a mathematical expression is called deterministic signal. Characteristics: no randomness or uncertainty in its behavior, fully described by a formula or algorithm. Example, x t equals to 5 sine 2 pi 50t plus pi by 3. Below is the graph of a deterministic signal. Non-deterministic signal, a signal whose values cannot be exactly predicted in advance. Characteristics: future values cannot be predicted. It contains elements of randomness determined by only probability or statistic. Example, stock market graph, weather data, etc. Below is the graph of a non-deterministic signal. Periodic and aperiodic signal, a signal that repeats its pattern exactly after interval of time called the period is called periodic signal. Mathematical expression for continuous periodic signal: xt equals to xt plus t. For discrete time, xn equals to xn plus n, where n is the integer. Characteristics: predictable and repeats infinitely and can be represented in the form of harmonics. Example, xt equals to a sine 200t, xt equals to cos t. Aperiodic signal, an aperiodic signal does not repeat itself over time. Mathematical expression, it has no finite period t that satisfies xt equals to xt plus t. Characteristics, no single fundamental frequency, often occurs in non-repetitive or random processes. Xt equals to e to the power t ut. And noise signal, even and odd signal. A signal is called even if it's symmetric about vertical axis. Characteristics, symmetry about y-axis. Cosine function and constant are even signals. The properties of even signals are xt equals to x of minus t, and xn equals to x of minus n. N is an integer. Example, xt equals to t square and xt equals to cos t are even example of even signal. Odd signal, a signal is odd if it is antisymmetric about the vertical axis. Characteristics, if flip the vertical axis then invert, it will get the original signal. Xt equals to minus of x of minus t, xn equals to minus of x of minus n. Example, xt equals to sin t and xt equals to t are example of odd signals. Below is the graph of a odd signal, which is a sine graph. Energy signal and power signal. A signal is called energy signal if it has finite total energy and zero average power. Expression, energy equals to minus infinite to infinite mod of xt whole square dt. Power equals to limit t tends to infinite 1 by 2t integration minus 2t mod of xt whole square dt. For discrete, energy equals to summation of n equals to minus infinite to infinite x mod of x n whole square, and power equals to 0. The characteristics are total energy is finite, average power is 0. Example, pulse signal, power signal. A signal is power signal if it has finite average power and infinite energy. Expression, for continuous, p equals to limit t tends to infinite 1 by t integration minus t to t xt dt, and energy is infinite. For discrete power signal, power equals to limit n tends to infinite 1 by 2n plus 1 sigma n equals to minus n to n x n square, and the energy is infinite. And the characteristics are power is finite and energy is 0. Example, sine wave, square wave, etc. Then casual signal and non-casual signal. A signal that is 0 for all negative time t less than 0 and t n less than 0. Xt equals to 0 for all t less than 0 and x less than 0. Exist only for present and future times. Physically realizable in real time. Example, xt equals to e to the power minus t ut. Non-casual signal, a signal that has non-zero values for negative time x less than 0, n less than 0. Xt not equals to 0 for t less than 0. Exist in past as well as future. Xt equals to, example, xt equals to e to the power 2t. Analog signal and digital signal. An analog signal is continuous in both time and amplitude. You can measure it at any instant of time. It can take any value in its range, not just specific steps. Xt, where t is continuous time. Example, human voice temperature changes over the day. Digital signal. The digital signal is discrete in both time and amplitude. It is measured only at specific time interval. The values are presented in finite steps. Xn, where n is discrete time. Example, MP3 audio, computer data, etc. Thank you.